Chapter 8, Section 2, Question 1. We're going to use the discriminant, which is b squared minus 4ac. But wait, didn't we learn about b squared minus 4ac back in Chapter 5? Yes, we did. Chapter 5, Section 5, we used b squared minus 4ac to see, can you even factor something? That was a pre-teaching for this lesson right here. All right. What we want to do is same as in Chapter 5, Section 8, we want everything on one side equal to 0, and we would like this leading coefficient to be positive. Here we go. Notice that I did not line this up with the x's because I don't accidentally want to get that to combine with something that is not a like term. But we do want this equal to 0. Yay! We need to find our a, b, and c numbers. A is the coefficient of x squared. Be careful. Many people say that a is 3x squared. That's the entire term. A is just the coefficient, meaning the number in front. B is the coefficient, meaning the number in front of x, which is 2. And c is the constant at the end, which is 1. Now, formula, plug, work, answer. That's how we do all those. Because that's getting a little low, I'm going to have a over here. Formula, plug, work, answer. b squared minus 4ac. Plug. Notice that I'm leaving parentheses everywhere a number goes. That's because some students have replaced the 4 with something else. Where did the 4 come from? The 4 is part of the formula. It has to stay there. So the b number is 2. The a number is 3, and the c number is 1. Some students don't put 2 squared. Some students put 4 because they know that 2 squared is 4. I know that 2 squared is 4, but I want to know, can you plug? If you can't plug, we have a different conversation to be having. I need you to be able to write the formula because you cannot forget this formula, period. It is really important. You have to be able to plug into the formula, and then you may use order of operations for work and answer. And so this is going to be 2 times 2 is 4. 4 times 3 is 12, times 1 is 12. And 4 minus 12, adding, subtracting, going from left to right, gives me negative 8. Hey, formula, plug, work, answer. That is a good idea right there. Then we have to determine the number of solutions. You're going to see these instructions underneath every single answer blank. So, what you're going to do is check this out. Plus, 0, minus. Last semester, I had a whole bunch of students who did that on every single problem. They got a lot of good points on this question. This is a negative, so it is a no real solution. Now, why is that? That is because b squared minus 4ac is part of a larger equation called the quadratic equation, where if you have x equals negative b plus or minus square root b squared minus 4ac, c, all over 2a. Now, be careful, all over 2a does stop before you get to the equal sign. Here, if I add or subtract a negative number, the square root of a negative number, the square root of a negative is going to be imaginary. That's why they're not real. There's no real solutions. If this number was 0, if you add and subtract the square root of 0, you're adding 0 and subtracting 0, which doesn't do anything, and it only gives you the one answer, because adding and subtracting 0 doesn't change the original stuff you had here. If it's a positive number, say it was 4, then you would add or subtract the square root of 4. If you add 2 and subtract 2 from something, you're going to get 2 different answers, which is why it's 2 real solutions. So you would have to formula, plug, work, answer, and then circle the correct answer. In this case, no real solutions. Wow! Our job as your loving and able math teachers is to make this really disgusting looking so that you have to work to get everything on one side equal to 0. Now, I want the x squared term to be positive. This is the only x squared term. I want everything to go to the left. I'm going to subtract 6, and I'm going to combine like terms with the other constant. I'm going to add 2x, There is no other x term, so I'm going to kind of squish it over here to make sure that it ends up in the correct place for descending order by degree. So 3x squared first, plus 2x, 5 minus 6 minus 1 equals 0. Wow, that's almost exactly the same thing I had there. I wonder how it'll change the answer. A is still 3. B is still 2. But this time C is -1. Notice that when I'm picking out my A, B, and C numbers, the number takes the sign that is right in front of it. So they always grab the sign in front of it and hold on to that. So here we go. For part B, formula, plug, work, answer. Some students say, I already wrote the formula over there. I don't have to write it again. Folks, if you have the $700 or so that you need to be able to fail your 121 class, please give it to me and then write the formula, because I don't want you to be failing either my class or your college class. So I am going to require you to formula, plug, work, answer. Write the dang formula again. Grr. All right. Plugging in something squared minus 4 times something times something. Many students say, I don't need to plug in. I need you to plug in. I am giving you points for having formula, plug, work, answer, circle. Formula, plug. B is 2. A is 3. C is -1. Here, this multiplication is something that gets a lot of students. So 2 times 2 is still 4. But this minus and this negative, 2 negatives make a positive. That is a plus. 4 times 3 times 1, 12, which will get me 16. 16 is now a positive number, so I would need to circle 2 real. And I hope you believe me that at some point, you will get one that when you combine like terms and everything, you'll get a 0, in which case it would be 1 real. Chapter 8, Section 2, Question 2. I left the quadratic equation up from the last question. That's important because we're going to be using the quadratic equation on this problem. Solve for x using the quadratic equation. You knew it was coming. I'd like you to get everything on one side equal to 0, and I would like this leading coefficient to be positive. It's negative. It's the only x squared term, so I'm moving everything to the right-hand side because I want this to be positive. Notice that I'm not lining it up with the x's because I want the x squareds to come first, because I want to write it in descending order by degree. Same thing from chapter 5, section 1. Ooh, I'm going to have to kind of squish a little bit to get this lined up with the x's. And then plus 45 and plus 45. All right, let's make sure that we have all those. All of these cancel opposite signs. Chapter 1, additive inverse. This is the only x squared term. It goes in the front. Negative 4x and minus 20x gives us negative 24x. And 45 plus 9 gives me 54. And you might say, hey, I could reduce that. I could factor something out. I could. Don't do it. We're just using this formula. That is the power of this formula, is you don't have to do that. You're going to just, I mean, hey, you could actually factor out a 4, but a lot of students get confused on this. We're going to just find your A, your B. Whoa, the B is not supposed to have the x on it. The B is just the number. Some students accidentally start putting in x's and x squareds. It gets very confusing. We're just supposed to be finding our ABC numbers. All right, A, coefficient should be positive. B, coefficient, C, coefficient. Now, can it work out if you had moved everything to the left and this was negative? Yes, but it would make the denominator negative, and many, but not all, college professors would have you fix that. So, let's get that fixed now so that we never solve it like that. Now, if you have a college professor who does not like the equals there, 0 being on this side, the way you fix it, just scooch the 0 onto the other side. It's the same equation. All right. Formula, plug, work, answer. I know I have the formula up there, but I'm going to write the formula here because, hey, you can't write the formula too many times. If you memorize this formula and you have it, my gosh, this is such a powerful formula, and many students still remember it years after being in my class. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. But wait, what if you don't like Pop Goes the Weasel? We also have Farajaka, negative b plus or minus square root b squared minus 4ac b squared minus 4ac all over 2a, all over 2a. But then you have to say everything twice, and it doesn't necessarily have the x equals. That might be a good idea because as long as we have the variable x, this is x equals. But what if, as you know, we have alphabet soup and we start changing this from x? Well, if this was a t equals, this would have to be a t equals. And it's only going to get worse. So maybe Farajaka is the way to go. Also, there is a version out there for the Addams family, but I'm not good enough at that one to sing it for you, so sorry. But I do know the story. Here it goes. Are you ready? The bad boy. Oh, hang on. Before we do the story, do you remember radical form? That this is called a radical? That's important. Radical also means cool. All right, here we go. The bad boy couldn't decide to go to the radical party. He was too square, so he was, square means, yeah, anyway, okay. He was too square, so he was turned down by 4 awesome chicks, and it was all over by 2 a.m. Here we go again. The bad boy couldn't decide to go to the radical party. He was too square, so he was turned down by 4 awesome chicks, and it was all over by 2 a.m. If that story helps you remember this formula, go for it. Here we go. Formula, plug, work, answer. Negative 24. Now, a lot of students say, negative 24 is positive 24. Are you plugging? I know it's positive 24. I want to see you plug. Plus or minus square root b squared. Oh, look. This is b and this is b. Huh. So, here we go. Minus 4 times a times c. Look at all these parentheses to make sure that I put those all in there correctly. A is 4, c is 54. But my vinculum, look how short it is. 54 is completely outside of it. We've got to extend that out here. Now, some students do all over 2a. Do you see how short this vinculum is? That is wrong. You have to keep going out this way until just before your equal sign, and keep going out this way, otherwise all these guys here are going to fall down, and 2a4. That's what plugging looks like. Make sure that this vinculum is long enough to have all of b squared minus 4ac. Make sure this vinculum is long enough to go under all of that. Formula, plug. Hey, what's next? Work and answer. Now you get to do negative 24 is positive 24 plus or minus the square root of, that's going to be a number, and 2 times 4 is 8. Give me a moment. I'm going to use a calculator. Be right back. That is negative 288. Oh no, vinculum extension, vinculum extension. You might say already, hey, that's a no real solution. Yes, but in chapter 7, section 7, we learned how to deal with that anyway. So you don't get out of it that easily. We're going to take a look at this 288. We know that the negative will come out as an I. This is an even number, so I could take out a 2 and be left with 144. And the negative 1 that will come out later. Oh, 144. That breaks up nicely as 12 times 12, in which case I already have my pair. So what does that do? That says x equals 24 plus or minus. The 12 comes on the outside. The negative comes outside as an I, and the 2 is stuck on the inside. And you might think, hey, I did formula, plug, work, answer. I'm done. But do you remember in chapter 5 when you thought you were done and you weren't? We're going to reduce this. So, a couple things you can look at. All outside numbers, they all divide by what number? Can they all divide by 8? No. Can they all divide by 4? Yes, they can. So what you could do is you could factor out of 4 from this outside number and this outside number. But you don't do anything to this inside number because outside numbers play with outside numbers. And then after you factor, you can cancel and write a better answer. But wait, this has an I in it. We would have to make it into a plus bi form. Gosh, if I was going to have to make it into a plus bi form, couldn't I have just split it up back here and just reduced it? Yes, you can. So, factor, cancel, and write a better answer is something that we learned back in chapter 5. But we also learned in chapter 7 about a plus bi form. We have to have this as two separate fractions anyway, so we might as well start off there. I have just separated it into two fractions. I am now going to reduce it. Hey, 24 divided by 8. Do you remember this in chapter 5, section 3, where I had you split them up into individual little fractions and reduce them? This is why. 24 divided by 8 gives us 3 plus or minus 12 divided by 8. Remember how we're reducing and factoring out of 4? We're going to divide by 4 here and get 3i squared root of 2. Divide that one by 4 over 2. This is an okay answer, but wait. This is an okay answer for this year. But if we're preparing you for college, then we're going to go for the separate answers. We have the negative version first, comma, the positive version second. Ooh, we are preparing for college. Neato. Now, there are some students who said, either I'm not going on to college after this, or they've said, hey, you know what? I just want to get the minimum I have to get through this class. This will still get you 100%. This will also get you 100%. This will get you 100% in college, though. Chapter 8, Section 2, Question 3. It's just like 7.6. It's also like a question in Chapter 6. It's also like a question in Chapter 5. 5, 6, 7, 8. All of them have this. Why? Because it's important. All right, so right now we're using the letter A because we want to let you know that we're making a change. In college, they're actually going to have f of x equals. That sometimes messes some students up. But for right now, we want you to be aware that if it changes here, what we're going to do is all the x's will become a's. So all these x's will become a's. And then we write equals 5. Notice that we don't have any f of a's here. We don't have any x's here. So what we did was this here says change all of these to a's and then write equals 5. That's what those instructions say. From Chapter 5, Section 8, you might say, hey, we already know how to do this. We're going to subtract 5 on both sides. And in Chapter 5's version, we just had to get it equal to 0 and factor and solve. So let's check that out. Hey, how does 12 break up so it subtracts to give you 3? 12 can break up as 1 and 12, 2 and 6, 3 and 4. Which of these subtracts to give you 3? That would be none of them. It doesn't factor. So even though you could factor, that doesn't work in this case. If you find a problem, lucky you, that would factor, you could have factored. But it's not going to help us here. Completing the square. Remember that completing the square works very well when this first number is 1. The first number is 1. And when the second number is even. 3 is not even. This would be a particularly difficult problem to solve using completing the square. Did you know we're in the section on solving things with the quadratic formula? I suspect strongly we're going to have to solve this using the quadratic formula. So A, lots of people do not like this. This A, B, C is different from that variable A. A lot of people don't like that. So A is still the coefficient, so 1, B is still the coefficient, 3, and C is the constant, which is negative 12. There's your A, B, C. And we have x equals, wait, it's not x equals anymore. Many students solve for x equals because halfway through solving one of these problems in chapter 5, 6, and 7, they change from a's back into x's because we're so used to using x as the variable. But as we go further in math, you're going to find that every single problem will use a different variable. We're starting with changing the x's into a's, and then from there are many variables out there. In fact, there's the entire Greek alphabet, which we'll be using those too soon. All right. Instead of x equals negative b, we're going to have a equals negative b plus or minus square root b squared minus 4ac all over 2a. Wait, Miss Jordan, why did you rewrite that formula when it's right up there? Because formula, plug, work, answer. If you learn formula, plug, work, answer, this is going to save you both in my class and also in your college classes. Now, be careful. That A is a variable. That A is our ABCs. Is it confusing? Heck yeah. What some students have done to help themselves is they use a capital A on these. I will take that, but frankly, I'd really rather you guys just learn that, sorry, they're different. So this is the variable, and that's where it goes, and this is the variable, and that's where it goes. Right now, if you use a capital A because you cannot tell the difference, I would accept it. But eventually, we're going to have capital A's and lowercase a's that mean different things, so you might want to get used to that now. All right, here we go. Negative b, negative 3. Hey, we don't have to have parentheses to plug that in. If you have parentheses, that's okay. b squared minus 4ac. Parentheses are often a good way to go. 3. Be careful. Some people look at this and see the negative 3 and they put a negative 3 there. But this is b squared. This is negative b. So, hey. All right. AC 1, negative 12. Now, some students say, but multiplying by 1, by chapter 1, the multiplicative identity says, I don't have to, multiplying by 1 doesn't change anything. Why do I have to plug it in? Well, because formula, plug, work, answer. Plugging says, hey, put that in there. All over 2 times a. There you go. Hey, I have plugged in. Even though times by 1's very easy to do, I want to know, can you plug into a formula and then work? Negative 3 plus or minus square root of 9. Remember, this is where a lot of students get messed up. Plus 48. 9 plus 48. Is 57. All over 2a, 2 times 1 is 2. Hey, look at these vincula that this one goes this way but not below the equal sign. And it goes all this way past the edge of the end of these. This one could be a little long, but hey, I'd rather it was a little long than too short. So be careful. Some students have it so short that it doesn't even go underneath that, and then they can't get the right answer. All right. 57. Does 57 factor? Let's see. 5 plus 7 is 12. 12 divides by 3. 57 divides by 3. And that goes in there. Let's see. 57 divided by 3. By the way, I love seeing all this work off on the side. I just don't want it all mushed in here. Yay! Well, 3 times 19 is 57, but 3 is a prime number, it doesn't break up any further. 19 is a prime number, it doesn't break up any further. And I don't have any pairs. I cannot simplify the square root of 57, but it is a good thing that I checked. So, for the purposes of this class, you may leave the answers like this. It is not an imaginary, so you don't have to split it up into a plus bi form. I will take it like this. However, to prepare you for college, I strongly recommend negative version first, comma, positive version second. Be careful. Did you see that I almost forgot to write that negative there? Ooh, tricky. So these should be the exact same things, only one positive and one negative. Kind of like conjugates from back in chapter 7. It's a thing. Chapter 8, section 2, question 4. It's like 5.8. If you remember, Jack, back in 5.8 when I had things like x equals 7 and x equals negative 3, where we got everything on one side equal to 0, x minus 7 equals 0, and x plus 3 equals to 0. This was not worth any points. The actual answer was when you took x minus 7 and the x plus 3 and made it equal to 0. That was the work. And then you FOILed it all together, which now we should be able to do in our heads and get x squared plus 3x and minus 7x would give us minus 4x and minus 21 equals 0. These were the 2 steps of work that I required back in chapter 5, section 8. Now, we're going to do the exact same thing, but with, all right, here we go. X can equal a 4 with the negative version first, and x can equal a 4 with the positive version second. Hey, that's how we've been writing our answers. We're going to take the answers and work our way backwards to find out what the question was. So, same way, subtracting 4 on both sides, adding square root of 3 on both sides. X minus 4 plus the square root of 2 equals 0. Ooh, square root of 3, I copied wrong. There we go. And then, same thing on the other side. We're going to subtract 4s. We're going to subtract square root of 3s. Making sure to copy correctly this time. You get x minus 4 minus the square root of 3 equals 0. Hey, we're going to have to take these, put them into parentheses, and multiply the heck out of them. All right, here we go. Boom, boom, boom. Do you remember in chapter 5, section 2, where we asked you to multiply trinomials times trinomials, and 3 things times 3 things gave us 9 answers? And then we had to combine like terms? Same thing. All right, so I'm going to, over here on the side, some of you may remember that we did this using the box. I'm going to do the first one with the box. I'll do the second one with the rainbow distribution method because I want you to know I will accept both of them. But some of the college professors may not have learned about this and might not accept the work shown like this. We have x minus 4 plus the square root of 3, x minus 4 minus the square root of 3. Now, some students did not like showing this work. And what they did was they said, hey, I have a positive 7 and in here it's a negative 7. I have a minus 3, so in here it's a positive 3. I have a positive 4, so in here it's a negative 4. I have a minus square root of 3. I have a positive square root of 3. I just change every single sign. Folks, I'm fine with that. This is because some students are having a hard time and I want everyone to succeed. So, hey, if this is what it takes to make sure you get 100%, you do that. I need to see this though. Just like here and here, because this is so long, I'm going to need to see that all the multiplication work with all blah answers, and then the final answer. Here we go. X times x is x squared. Negative 4 times x is negative 4x. And over here, outside number and then inside number. X on the outside, square root of 3 on the inside. Ooh, that's kind of yucky. Negative 4 and x. Negative 4 x. Negative 4 times negative 4. Negative times negative is a positive. 4 times 4 is 16. Negative times positive is negative. Outside, inside. 4 on the outside, square root of 3 on the inside. Ew, that looks yucky. Here we go. Now I have an x on the outside with a negative, so negative x, and a square root of 3. Negative times negative is positive. 4 on the outside, square root of 3 on the inside. Negative times positive is negative. And hey, a pair of 3 on the insides from chapter 7, that gives me a 3. Why does it give me a 3? Inside things play with inside things, so that's the square root of 9, which simplifies as 3. Now is the fun part. We get to cancel, and it's one of the reasons why, if you use this box method, it's really nice because it will actually kind of check yourself. A positive x squared of 3 and a minus x squared of 3 cancel. A minus 4 squared of 3 and a positive 4 squared of 3, these cancel. If you use the box and you have done this correctly, only these will ever cancel. In which case, only the 5 remaining boxes are left. So you will get x squared. X squared. The x terms will go together along this funny little peanut here that reminds you to add them. Negative 4x plus negative 4x gives us negative 8x. And then these two things here go together along this little peanut here that says, hey, add these, and 16 plus negative 3 gives me 13. Make sure you have equals 0. Hey, look, I need this, I need some sort of work, and I need the answer. Yay! But wait, there's this one. So, we talked about changing the signs. We talked about changing the signs from positive 7 to negative 7, from negative 3 to positive 3. The students in 121 are going over this right now. So let's see if we can do this. The important thing is you have to have this x in the front. A lot of students say, hey, positive 2, negative 6i, positive 6i, and they forget to put the x. And then they come up with a single number, and they're like, gosh, this is so easy. Folks, it's supposed to come out looking like this. It's supposed to come out looking like a trinomial. Make sure you have that x at the beginning. 2, negative 2, plus 6i, minus 6i, equals 0. Step 1. Step 2, we're going to have to distribute 1, 2, 3. That gives us x squared minus 2x minus 6i. 6i is a number in front of the variable x. Hey, that looks kind of like this first line here. Guess what? When we distribute the next one, it's going to look like the second line, and the third one will look like the third line. So it's really doing the same thing, only in a slightly different format. 1, 2, 3. Do you have to draw the little arcs? No, you don't. All right, here. This is going to give me negative 2x. I strongly recommend that you line them up because we're going to have to combine like terms later. Negative 2 times negative 2 is a positive 4. This is an ix. I'm going to actually scooch this over so that it's a plain old number column. And then positive 12i. That's an ix. I want a positive 12i over here. All right, so that's going to look kind of like this middle row here. Boom. All right, here we go. Last but not least, 1, 2, 3. I have a positive 6ix. This is a negative 6ix, and I'll put the positive 6ix in the same column. Is it going to cancel? Yes, it is. Are they going to cancel? Yes, they do. All right, keep going, though. We have to find all 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 things to find, so keep going. That's a negative 12i. Hey, that goes in the column with the, with the 12i. And this one over here, you might think of putting it here on the side. That is a negative 36i squared. But do you remember from back in chapter 7, section 7, that I squared is equal to negative 1? So negative 36i squared makes it into a positive 36, which I will put over here by our nice little numbers. so that our constants and our constants can go together. Blammo, we're putting them all together. X squared is here. Minus 2x and minus 2x gives us minus 4x. Kind of like, that's the x squared, and here our minus 4x and minus 4x went together to get minus 8x. Here our minus 2x and minus 2x gives us minus 4x. These cancel, these cancel. 4 and plus 36 go together and give us 40. 16 and minus 3 go together and give us plus 13. These cancel, and then that's it. But wait, equals 0. Why do we have to keep putting this equals 0? It's because it's a polynomial. That's a polynomial. Equation equals 0. That's how we're doing it, is we want a polynomial equation. That's a polynomial times a polynomial when we were multiplying polynomials back in chapter 5, section 2. It's an equation because we have the equals 0, polynomial equation. Chapter 8, section 2, question 5, type 1 of 2. Oh no! That means these hardest questions, which prepare you very well for college. There's 2 different types because there's so many choices about what can help you for college. This is one of them. So, revenue. Hey, we had revenue back in chapter 5 where we had profit, revenue, and cost. Revenue is that money we take in. Cost is the money we have to pay out. Profit is revenue minus cost. Because, hey, people give you money, but then you got to pay for stuff too. That's where we got the profit, revenue, and cost. Now, Miss Jordan sells boxes with eyeballs. There are some students who actually were sick enough to think I was selling boxes with eyeballs. That's disgusting. So here I have a picture of a box with little eyeballs painted on them. They're supposed to be cute. What is wrong with you people? Gosh. All right, Mrs. Jordan sells n boxes with eyeballs, n less than or equal to 25. I am selling less than or equal to 25 boxes like this. At a price of, oh my goodness, what the heck is that? Dollars per box. How many boxes must be sold to have a revenue of $460? That's a lot of strange variables in there. Seems odd. Now, let's think of an easier problem. Mrs. Jordan sells 3 boxes with eyeballs at a price of $5 per box. How much money does she get selling 3 boxes at $5, $5, and $5? And you would get $15. How did you get that? We took 3 boxes times $5 per box. Hey, dimensional analysis from back in your science classes gives you 15. $sign is the only label that remains. Hey, that is our formula. Now, let's take a look at the actual question. The actual question says 3 boxes. Ours says n boxes times $5 per box times, oh my gracious goodness, all of this stuff here. Remember that our college professor likes the 0 in the front. Equals the amount of money we get. All right. Hey, this says to me distributed property. Some people might say, hey, but what do you do with this? What do you do with this? Keep remembering that. This will play a part later. It's coming. All right, here we go. Hey, distributed property from back in chapter 1 to the rescue. Woohoo! Look at that. Awesome, awesome, awesome. Yay! Ooh, I want to get this all on one side equal to 0, and I'd like the n squared term to be positive. But the n squared term is negative. I want to bring everything onto this side, subtracting the 25n. Oh, this is going to be hard because it's really hard to just squish everything onto this side. But we're going to try, and we're going to have to write it in descending order by degree, despite the fact that, oh my gosh, that looks like a mess. Whew, all this stuff cancels and we get 0 over here. Hey, equals 0 is important. And then descending order by degree, we want the n squared term first, because it has a degree of 2. We want the minus 25n to go second, because it has a degree of invisible 1. And we want the plus 460, because it has a degree of 0. It doesn't have any variables on it. Yay! Neato! So, this is our formula, and I don't know about you, I don't want to factor that, because it has a decimal in it. Now, some of you might be like, I can do it! Folks, you could. Alright, but what section are we in? We're in Chapter 8, Section 2. What is Chapter 8, Section 2 about? The quadratic equation. So, what is A? A is 0.1. What is B? B is negative 25. Remember that the number grabs onto the sign right in front of it, and C is 460. Yay! What was our quadratic equation? X equals negative B plus or minus square root B squared minus 4AC all over 2A. Hey, did you notice? I wrote X. That's not right. Why is that not right? Because our formula doesn't have an X in it. What are we solving for? We're solving for N. Remember, this is going to come into play soon. Do you also remember formula, plug, work, answer? Folks, formula, plug, here we go. N equals negative 25, because we're plugging plus or minus square root negative 25 squared. Hey, parentheses absolutely required, right here. You have to have those or it is wrong. Minus 4 times 0.1 times 460. Wow, I went so far past. All over 2 times 0.1. I certainly hope that you have a calculator and that you're really not using the calculator on your phone. First of all, because if you try and use that during a test, at this school that counts as academic dishonesty, probably get a 0. And your phone confiscated, at least till the end of the day. So, don't do that. Negative 25 is 25. Plus or minus square root. I don't know about you, but I'm going to put all this into my calculator. I'm going to put in parentheses, negative 25, parentheses squared, minus 4, parentheses, 0.1, parentheses, 460, parentheses. I'm not going to put it with the square root on it because I just want to know the discriminant. Do you remember at the very beginning, 8.2, question 1, I just wanted you to find b squared minus 4ac. Same thing here. I want to find this. Give me a moment. I'm going to do this in a calculator. This is 441. All over 2 times 0.1, which is 0.2. Hey, did you know that 441 comes out nicely? You could put into your calculator the second and the square root button. So second, and then above the x squared is a square root. But the thing is that your calculator is so powerful that if you actually have a TI-83 plus or TI-84 plus that you're supposed to have for this class, part of what we're doing is showing you how to use it so that when you go to college, you're not trying to learn a whole bunch of new math and also how to use the calculator. I want you to learn it now while it's still safe. So here, what I want you to do is to type in all of this. If you have one of the newer operating systems, usually on a TI-84, not a TI-83, you can hit alpha and y equals the button, which will give you a pop-up menu where the first thing says numerator over denominator, and if you hit enter, or the number 1, it will actually give you a top and bottom fraction like this. Whereupon you can write 25, there is no plus or minus button. Remember how we had you separate it into 2 different equations? That's why. You put in the negative version first, with all of this stuff here, hit enter, hit second enter to bring that back again, use your cursors to get back over here, and where the minus was, you just hit plus. It'll change it. You can just hit enter, it'll do it again. You don't have to get to the end before you hit enter. You can hit enter from in the middle of this. What I want to talk about though is, hey, the people who have this, It looks exactly like this, and you hit enter. Yay, don't put in the n equals. The people who have the older operating system, though, you're going to have to know some things. You'll need a square root that has a beginning of the square root and an ending of the square root. You will have, because there's a binomial in the numerator, you're going to have a parentheses to begin and a parentheses to end your numerator, because you're only allowed one line of work. So, for those of you who have the older operating system, this will work even with the newer operating system, so everyone can do it this way. Parentheses, 25, minus version first, square root. If you have a very old operating system, it'll put a square root with a beginning parentheses. If you have a newer operating system, the vinculum on the top will extend out. So then you put in 441. Older operating system, you have to press an end parentheses. Newer operating system, hit a right arrow to get out from under there. And then end parentheses. This is the numerator divided by 0.2. That's how you would do it. You would hit enter, it would do that. Then second enter will bring it back again, and this will reappear, and all you do is instead of minus, just type over that with a plus. Many students retype the entire thing. Folks, it's a computer. It knows how to copy and paste basically. So just use it again. All right, and then if we do that, we will get numbers and different numbers. For this first one, we will get n is equal to 20, comma. The other one was n equals 230. Now, what was n? How many boxes? Hey, from our English class, this is a writing prompt. How many boxes? This many boxes. But wait, remember this? N is supposed to be less than or equal to 25. The answer is supposed to be less or equal to 25. It's not this one. It is n equals 20. Hey, it's a word problem. We have to label it boxes. If we wanted to show this as a sentence because of our English writing prompt, then you would say, how many boxes must be sold to have a revenue of $460? 20 boxes must be sold to have a revenue of $460, period. Yay, English! Now, let's take a look at why I got such different numbers, but I wanted that one. It all has to do with this very first thing here, one of these. A negative n squared. Do you understand that an x squared looks like that, so an n squared would look like that, and a negative from back in chapter 3 would be an upside down parabola. So, if we have an upside down parabola, this says, when will we hit $460? We will hit $460. All this parabola will equal $460 in two places, here and here. It will hit at n equals 20 boxes, and also here at n equals 230 boxes. Why does our formula go like this? Folks, in this business, I'm making boxes, I'm selling boxes, yay, yay, yay. Someone says, hey, I want to get hundreds of boxes. And I'm like, hey, I don't have that kind of stock on hand. I bought these boxes on sale. Oh my gosh, I'm going to have to go out and pay extra. I'm going to have to hire some more people to get all this work done. Oh my gosh, it eats into my money. And so the money I get is coming back down again. So I could get the same $460 by selling 20 boxes or by selling 230 boxes. I don't know about you, but if I can get the same amount of money by doing 20 little boxes all by myself, yay, look, they're so cute, or 230 and I get the same amount of money, don't do that. That's working harder, not smarter. This is working smarter, not harder. That's where we want to be. That's why on this particular problem, it's going to be the smaller number, because we want to work smarter, not harder. I've had some students who said, I want to work harder for the same amount of money. You go do that, but I'm going to mark it wrong because of that. That tells you, pick the smaller number. Chapter 8, Section 2, Question 5, Type 2 of 2. Yucky numbers. It's not really that bad. Is it really yucky? Let's take a look. Solve using the quadratic formula. Hey, we know the quadratic formula. Our old buddy x is still here. We're going to start off with formula. For formula plug work answer, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Hey, formula. All right. Hey, formula plug work answer. Will just the formula get you half credit? No, it won't. But formula and plug, that'll get you half credit. All right, here we go. A is the invisible number in front of x squared, which is the invisible 1. B is the number in front of x. Well, that's nifty. That's negative with a square root. You make sure that it grabs the sign in front of it. And what is C? C is the constant, which is negative 10. Wow, that's a lot of negative things. Good job. All right, make sure that this vinculum here does not go underneath the equal sign. And make sure that on this side it goes past and it goes past. Because if you have these vincula being way too short, I absolutely will take off points and you won't even get credit for writing the formula down if you do something like this, which I've seen a lot of students do, and they do that. I'm not going to give you points for that. Make sure that this goes all the way under. Make sure that this goes all the way over. That is correct. I hope you're watching, because somebody is going to lose points on that. Plugging, negative b plus or minus square root b squared minus 4ac, extend vinculum, all over 2a. Look at all those little landing pads for our numbers when we're plugging in. B's go here. That is negative square root of 5 and negative square root of 5. A's go here. A is 1. C goes here. Aw, C only gets one place to go. Hey, formula plug. That gets you halfway, that gets you half credit. Here, x equals negative square root of 5. That is a positive square root of 5. How nice. Plus or minus square root. Remember the discriminant from Chapter 8, Section 2, Question 1. You just put into your calculator, parentheses, negative, the square root of 5. If you have the old operating system, you'll have to close that off, close this off, and then square it. Minus 4, parentheses 1, parentheses negative 10. You might recognize this from this pattern we've been doing since Chapter 1. I, knowing that this would be coming, have been giving you problems like this in this format since Chapter 1. Your calculator could then enter, just do it for you. That's going to give you positive 5. Negative makes it plus 40, and you will get the square root of 45. Do you need to do this by hand? Heck no! We have calculators. Can you do it by hand? Absolutely! Using your brain is a wonderful thing. Now, you might think you're done, but you are wrong, because formula plug, work and answer, remember that work and answer? What can we do with the square root of 45? Let's take a look at 45. Some of you already know that the square root of 45 simplifies. That breaks up into 9 times 5, and 9 breaks up into 3 and 3. Make sure you bring down this 5 so we don't lose it by accident. Because some people say that the square root of 45 is 3, and they forget about that. Here we go. X equals square root of 5 plus or minus 3 on the outside, 5 on the inside. And you might think you were done, but you'd be wrong. We need to split this up. So we're going to split up into a negative version and a positive version. Here we go. X equals the square root of 5. Here's the negative version. And then x equals square root of 5, and here is the positive version. Ooh, we can combine like terms. Folks, on this question, if you can't combine like terms, I think it's probably gone horribly wrong. Check your work. That gives me negative, let's try that again. Negative 2 square root of 5 over 2. That reduces to negative square root of 5. How about this one? Invisible 1 in front of that, so we get 4 square root of 5 over 2. Outside numbers can reduce with outside numbers, but you can never reduce inside numbers with outside numbers, and that gives me 2 square root of 5. Folks, you do have to get all the way to this. So when I said formula, plug, work, answer, formula, plug, wow, look at all that work. Answer. Folks, this is not a one-step solution. Why not? It's a question 5. This is supposed to be preparing you for college. They don't have like cute little problems in general. So formula, definitely do the formula. Plug, definitely do the plug. Look at all of this simplifying, and some of the simplifying I did in either by hand or on with my calculator over on the side. Simplifying the square root, simplified radical form from back in chapter 7. Rewriting them, one with a negative and one with a positive, negative on the left, positive on the right. Combining like terms. Gosh, we were combining like terms back in chapter 7 on these. And then reducing fractions. Woo! That is a problem. But preparing you for college, that's what we're doing.